Okay, so welcome to the correction of last lecture. As I wrote to you, in the Ziggurat method in step 5, there was a problem with picking the index of the rectangle. And I already got some nice corrections from you, which is really great. So now I would like to explain what was wrong and how we can fix it. And for this, well, let's dive into step 5, so sampling from the main part. So we did this by acceptance and rejection with this proposal pseudo-density. And as I told you, since, well, acceptance and rejection has a nice geometric interpretation, this is actually quite simple. So we sample uniformly on the set, and then we keep the first component as a sample if this test here is satisfied, and otherwise we reject. So let's look at the picture. So, well, G is our proposal pseudo-density, and we wanted to generate a point under this proposal pseudo-density. And I explained to you, okay, so in this case here we have 7 rectangles and the base strip. And what I explained was, okay, we pick one of each with equal probability. And that's where the mistake comes into play, because we truncated the tail. So here the last strip, which is not R8 but R8 star, we don't pick with the same probability as the other ones. But this can be fixed really easily. So we just have to modify the sampling from the index. So again, we sample first the rectangle and then the uniform distribution on the rectangle to sample from the uniform distribution on AGB. But for this, as I said, we have to modify the probabilities. So first we need this rectangle R star n, which is 0 to R times 0 to f of R, which we get from the base strip by cutting off the tail. And then we need this probability Q here, which is nu divided by n times nu minus the integral from R to infinity fz dz. So nu was the area of one rectangle, and that's the area of all the rectangles. So n times nu was the area under the pseudo-density, but we are cutting off the tail. Well, and then we are proceeding as follows. Well, we can write the uniform distribution on AGB in this way. So it's a uniform distribution on RJ plus a uniform distribution on R star n times the corresponding weights. So we are picking RJ with probability Q, and R star n we are picking with probability 1 minus Q. Okay, and that's all we need for the fix. So in the first step, we don't sample I uniformly on 1 to n, but corresponding to this measure here. So we call it that epsilon j are just the Dirac measures. So we pick an index j between 1 and n minus 1 with probability q, and the index n we are picking with probability 1 minus q. And the rest we don't need to change at all. So here's the pseudocode adjusted. So here we need this q, and here's the adjusted sampling of q. Okay, so you might wonder why in the Ziggurat algorithm, if we need to do this case distinction, why we choose nu for this rectangle, nu for this rectangle unto here, and also for the base strip. That's because, well, you can mix the tail and the main part again to make the algorithm more efficient, and that's also what Marsaglia and Tsang did. But presented in this way, it's much less intuitive as we did it here, because we cut off the tail first and split everything, and this intermixing makes the algorithm at first sight a bit more difficult. But let me explain to you what I mean by this mixing. So here's the Marsaglia and Tsang version of a ziggurat, and well, there's no direct splitting between the main part and the tail part. So what they are doing is they are doing exceptional sampling of the absolute value of Z with this proposal pseudo density here. So the main part for the main part of proposal pseudo density is as before, but the tail is not cut off directly. So we keep the pseudo density for the tail here. And then, well, we can pick a set from R1 to Rn in this way. So by just sampling the index R uniformly on 1 to n. And then, well, we have to look at the case I equal to n in more detail. If I is less than n, then everything proceeds as I presented it to you. But for I equal to n, well, we need to decide whether we are in the tail or whether we are in the main part. And this is done by sampling from this Bernoulli random variable here, which has the right probability. So if v is equal to 1, then we are in the tail, and we are using the algorithm for sampling from the tail. And if not, well, then we can just compute r times w1 and accept this as a sample from the absolute value of Z. Okay, and this explains why we have constructed R1 up to n with equal probability. But as I said, at least in my understanding, starting with this here first, it's not so easy to digest, but after all the preparations, the step 2 here and 1 in combination are easier to digest. Okay, and here's a pseudocode. Well, that's basically 1-to-1 the same algorithm as I showed you here. Okay, that's all for the correction, and lecture 8 will follow soon.